Okay, we're looking at LSAT 42, and this is December of 2003, Logic Game 1. A panel of 5 scientists will be formed. The panelists will be selected from among 3 botanists, 3 chemists, and 3 zoologists. Selection is governed by the following conditions. Okay, so what I try to do here, these are the variables, as you see right here. What I attempt to do is keep them separated, and so intuitively it's not as awkward. When you're given this many variables and this many different subsets of those variables, this is definitely intuitively awkward, very difficult to remember. So I put a circle around one, capital around the other, and lowercase with another. I mean, if you are better at seeing like a diamond and a square, whatever you want to do, but try to separate it as best you can so that you you can avoid this awkwardness that we've got. Okay, and so what we know right now is we do have a grouping game, and we have 5 people that are going to be on the panel, and then 4 that are not going to be on the panel. So we don't know yet, but there is no sequence in this game. So this is just a pure grouping game. We want to know who's in the panel and who's not in the panel. The not in the panel is actually smaller because there's only 4 people that are in that particular group. And if you know who those 4 people are, then you automatically know who the other 5 are. Okay. Selection is governed by the following conditions. The panel must include at least 1 scientist of each of the 3 types. So I have a minimum of 1 of each type. If more than 1 botanist is selected, then at most 1 zoologist can be selected. So if we have more than 1, which is 2 or 3 botanists, and botanist is in lowercase, then I have then exactly 1 zoologist, okay? And I'm going to kind of do this so I can keep myself, so we can understand who we're talking about here. Lowercase and circular. If 2 or 3 of my circular is shown, then only 1 botanist can be shown. So, this is going to be a critical contrapositive statement in this logical game. Okay, F cannot occur with K cannot occur with M. So basically, if we have K on the panel, we know automatically that F and M cannot be on the panel. And then the last rule, if M is selected, then both P and R could be selected in this. If P or R is not selected, then we cannot have M. And so the question is, can we solve the scenarios? And in short, not really. Creatively, if you look at it, you might be able to come up with something, but it's not worth it. And the way that we know it is we're not really given any first order rules here. And, if you look at this, we have 2 exclusion rules and 2 conditional rules. According to my philosophy, if you don't have any first or second order rules, we don't want to try to solve the scenarios. Now, what we should pay attention to is numerical distribution. We have 3 groups, and a minimum of 1 of each has to go. So what it can look like, if I look at numerical distribution, is 1, 1, 3, or 1, 2, 2. That is all that can occur with regard to numerical distribution. Okay, so other than that, we're in a nuts and bolts type of game here. If I wanted to, work with something, I could look at, K can't occur with M, so I could either have 1K, 1L, 1 LM. I could start identifying with this group. I mean, maximum 2 could go. And then minimum 1 could go, but there's a lot of different scenarios that can be created from it, and there's simply nothing to bite my teeth into to limit the scenarios, so I'm just going to proceed with this game as I find it to be a nuts and bolts game, okay? Alright, which one of the following is an acceptable selection of scientists for the panel? Okay, the first rule says that we have to have at least 1 scientist of each type, and if you look at B, we have G, H, K, L, and M. Well, that's only B and C. We don't have a Z there, so B should fall out automatically. The second rule says that if we get more than 1 lowercase letter, or FG, more than 1 FG or H, then we cannot have, then we must have exactly 1 zoologist. And if you look at A, we have an F and a G, and a P and a Q, so A falls out automatically. So now we're looking at merely C, D, and E. And if we look at rule 3, F and K can't be together. They're not. So we just go to the next rule. If we look at rule 4, K and M can't be together. Well, that eliminates D. And then E, if M is selected, P and R must both be selected. So E falls out, and the answer to the question is thus C. Okay, question 2. If M is the only chemist selected for the panel, then which one of the following must be true? Okay, so it's time for us to just build a hypothetical. So we have M is the only one selected, and that's going to put K and L out, okay? And if we have M, then we know for a fact that P and R must also occur, so let's just put them in right now. Okay. All right, so which one of the following must be true? Okay, well, let's take a look. We have K is out, so the question becomes, what we have right now is we have 2 or more zoologists. Okay, we have 2 or 3 zoologists. Then we know that we're going to only have 1 botanist. So we know that this would have to be F, G, or H. And then that means that Q would have to occur right here. Okay, so that's what must be true. Let's scroll through and see what answers help us. F and G are both selected. That cannot be true. G and H are both selected. That cannot be true. H and P are both selected. That looks like it could be true. Okay, but it's asking us what must be true. F, G, and H are all selected. That cannot be true. There's simply not enough space for that. And then P, Q, and R are all selected. E is the correct answer to the question. Okay. 3. If four of the scientists selected are F, L, Q, and R, which one of the following must be the 5th scientist selected? Okay, so let's take a look at what we got. We have F, L, Q, and R. Okay, well, again, we have 2 or 3 of the zoologists being shown here. So that means we can only have 1 botanist. We've already got the botanist. That means G and H cannot go. Okay, G and H are out. And so we're looking at who's left is K. Okay, but the other thing is F cannot occur with K, so K is going to fall out as well. So who is left over? We have M and P left over. Okay, and then let's look at this. If M were to go, okay, we have a rule with M. If M were to occur, then we'd need both P and R, but there's only 1 spot left. So M cannot be there because P would be required to be there, so M is going to fall out. Okay, and then we've got P. So this is the variable that actually must occur, and thus the answer to the question is E. All right, let's look at the next question. If P is the only zoologist selected, which one of the following must be true? So I'll put my P here. I have Q and R has fallen out. Okay, that also means that if R is out, M also falls out. Okay, so what am I left with? I'm left with F, G, H, K, and L. And now the other thing we need to ask ourselves is this. If K were to go in, okay, that would force F and M to be out. So I believe this is all that we know right now. This is what must be true, okay, from what we can discern. So now we just have to actually work through the scenarios. Which one of the following must be true? If K is selected, G cannot be selected. So let's just give that a try. My P should be circled here. So here is K, and the question becomes, can I put a G there? All right. Let's see if we can fill it in. If K is in, we know that F and M have to be out. Okay, so I've used now K and F and G. That leaves H and L to be left over. And is that okay? Let's just look through. I do have 2 or 3 botanists, then I have exactly 1 zoologist. That's fine. F can't go with K, K can't go with M. If M is in, M is not in. So this one works. So I have disproven this. Okay, so I don't know if I adequately explained this. When it asks me what must be true, if I try to disprove the conditional or disprove the necessary portion. So it said if K is in, G cannot be in, but I placed G in and made it work. So I know that A cannot, A can occur, or the opposite of A can occur, so it's not a must be true that G cannot be selected. So now let's look at B. If L is selected, F cannot be selected. Well, that appears to be the case, but let's see what happens here. So I have L being selected. Let me place F as well. Okay, and I know that M couldn't be. Okay, so if F is there, K can't be there. Okay, so that's out. And then I'm actually placing G and H. Now, can that be? If I have 2 or 3 botanists, I can only have 1 zoologist. That works. F can't go with K, K can't go with M. If I have M in, I don't. So that works. L can be, if L is selected, F could actually be selected. So B is not a must be true. Let's look at C. If exactly 1 chemist is selected, it must be K. Well, here in this hypo, I have 1 chemist selected and it's L, so that doesn't, that's not, C is not a must be true. And then D, if 2 chemists are selected, F cannot be selected. Let's try that. P, and if I put my Q, my R, I know that M can't go, so that means of my chemist it has to be K and L. And if K occurs, then I know that F can't occur, so D is the correct answer to the question. F would be forced out, and I would be placing G and H here. So D is the answer. If 2 chemists are selected, that would mean K and L. F would have to go out, so that would be the end of that. And if we look at E, if exactly 2 chemists are selected, G cannot be selected. Well, here I have 2 chemists selected and G selected. So I've proven that D is the correct answer to the question. All right, let's look at 5. If G and H are among the scientists selected, then the panel must include either. Okay, well, let's see. I have G and H selected here, but it'd probably be better if I just took a look. Okay. Well, if we look at what we've already created, okay, if we have a G and an H, all right, it says either F or K. Well, I have K in both, so A is a possibility. F or M, I've got them both out, so B would fall out. K or M, well, I've got both K's there, so that would have to be. M and Q, I've got those both out, so that doesn't have to be. And right now, I've got a P also in. So we're looking at A, C, and E as our answer choice. So let's go through and take a look at what we have. So if we have G and H in, okay, so if we have G and H are among the scientists selected, those are 2 or 3 botanists. We can only have 1 zoologist, okay, so that's, okay, we can only have 1 zoologist here. If we only have 1 zoologist here, we know that 2 of the zoologists are out. And then that also means that that M would be out, because if M occurs, we need 2 zoologists in. So M is now out. What are we left with? Okay, that's what we have to basically ask ourselves. Well, P, Q, and R are all taken care of here. Okay, we're left with K and L, and then F. So if we look at that, F and K cannot go together. We have 2 spots here and 1 spot left over. If I put F here, K can't go here, and that forces L to fill up the spot. So what we're ending up with here is that we would have to place an L here, for sure, and then F or K or F. And all of these variables could change in and out. Okay? P, Q, and R could do whatever they wanted to do. So L would have to go for sure, but we don't have L as a choice in any of these. So if we're looking at A, C, and E, would K and M have to, either K or M have to go? No. F or K has to go. It could be F and M instead of K and M, so C would fall out. P or Q, well, that doesn't have to be because we could put an R here, so that wouldn't work. But F or K, that actually has to happen. It's got to be one of them. If both of them are out, we don't have enough people that could actually go. So we know that the answer to the question is A. All right, that concludes Analytical Game 1. That's LSAT 42, December of 2003. Thanks.